Okay, so oops, sorry about that. Okay, so last week we talked about arrays, which are the basic data structure we have been using quite a lot even before Adsoof, but we saw them a bit more in detail and how we can use them in particular for this module in order to do algorithms and data structures and things like, for instance, iteration and recursion. So today we're going to look at some other Java classes, built-in classes that will be of use, and if you like, they're very like basic blocks of data structure programming. And what we'll be seeing basically today is two such classes, strings and array lists. So strings again is it's something you have seen before. So this is a bit of a recap for you. Why did you do that? So strings are defined, Java objects defined by the class string. And then you have an object string. Well, if you have an object str, which is of type string, then there are several things you can do. You can get its length by using this field. You can call a method char_at and then give an integer expression, and it'll give you the character at that position. So if you like, strings are like arrays of characters. And also, you can in different arrays, you can have a literal representation of a string. So for instance, this here is the string of length 4, with the characters FRED. Okay? So strings look a bit like arrays, but one very important thing is that you cannot change their values, so they're immutable. And you may remember that arrays are immutable as far as their length is concerned, so you cannot change the length of an array, but in string, things are even stricter. Strings, you cannot even change their contents. So once you create a string, it's just there, and there's nothing you can do about changing. The only thing you can do is create a new string, and for instance, reassign the variable that holds your old string to the new one. In particular, one might be tempted to say, okay, I can fetch a specific character of a string by using char_at. So what if I have like, for instance, suppose I have that, so I have set str to be Fred. Can I say then str char_at, so this is 0, 1, 2, 3, okay, this 4 would be out, so let's 3 equal, now I want to change Fred to, I don't know, to Frep. And well, so the idea here, the result here is that this will not even compile, because what we're doing here is actually you're calling a method, this will return a value, and if you want then, well, you cannot have a method that returns a value on the left-hand side of an assignment, you need a variable. So this is like bad code. So it wouldn't even compile. And the moral here is that strings are immutable. You cannot change the contents. Okay? All right, so we have seen that. Okay, more operations we can do with strings. So we said we cannot change a string, we cannot change its value, but there are several methods that allow you to change a string constructively. So if you have str being a string, and then you want to replace a character 1 by character 2 inside the string. So there is a method for that, it's called replace, and it does this for you. What the method is going to do, quite importantly, is you give it a string, then if you go, so str.replace would create a new string, and we'll have replace, for instance, if you, here you have ch1, here you have ch2, and so on. But the old string remains there. So this is what we have talked about as being constructive change. Other methods for constructive change is, well, you have a string, and if you can call this method to replace all lowercase case to the corresponding uppercase, and so on. And there's also this tree method which removes, for instance, leading and trailing blanks. As we said, it's very important to note that all of the above are constructive. Okay? And then with arrays, we spend quite some time trying to copy arrays and copy parts of the arrays. Well, for strings, you don't need to put a lot of effort because there are methods. Well, even with replace, if you remember, we had change methods to change elements of an array. You don't need to do that anymore because we have built-in methods for that. So for instance, if you have a string, str, and you call the substring method, so suppose I have a string like this, and this has, I don't know, 0, 1, 2, 3, 4, 5, 6. I can get a substring, let's say 2, 5, and this will return a substring that starts from position 2 and finishes just before 5. So basically returns a string of length 5 minus 2, 3. So if you like, substring P1, P2 returns a substring of str that goes from P1 inclusive to P2 exclusive. Okay? So in particular, if I want to take all the substring here of str, what I would say str, what would I say? Substring, and then start from 3, and then finish just before the end. So I can actually say this. Is it length? Oops. Okay. So this is what, and actually, if you want to do this even more simply, there is this method is overload. You can just give one index and returns the part of the string starting at position B and going up all the way to the end. And you can also compare the strings for alphabetic comparison. So if you have str1 compared to str2, then this will return a negative integer. If this guy is before this guy alphabetically, positive is the other way around, and 0 they're equal. So these are basically methods for string processing, and maybe it's going to be simpler if we look at some, well, or nicer if we look at some examples. I have prepared some examples here. Maybe I can make this a bit larger. Okay. So I have this toy file here. I don't know why this is here. So some demos. So I create a new scanner. So scanner is a class, is an object that allows us to read input. I will only use scanner here in order to make the demo and press enter after each thing I show in the demo. And maybe I can even actually swap. There you go. So I have these examples here. Come on. So let's say I create a string, never odd or even, and then I will print it, and then I will print its length. Well, in the first slide I had length here without brackets, so that was obviously a typo. You can correcting myself. Then I will call trim and then see what it prints. And then I will replace empties by dashes, and then convert it to uppercase, then take a substring, and then compare the substring with my original string for equality. Now, okay. Let's see where this is. Oops. Okay, excellent. Okay, we don't really need to see the code because the code is the same, more or less, to the code we have here. So we just did what this prints. It would be great if this was larger. Okay, never mind. I'll leave this for now. Okay. Okay. So if you cannot read this, this says never odd or even. So I just printed, take from here, so I just printed my string. And then I'll say, okay, what is the string length? Okay, I don't want to count it, it's 17. Now I want to trim it. So when I was writing this, I was hoping that if I trimmed it, I would take never odd or even without blanks, which we have seen actually last time in Automata. It's a palindrome. You can read it the same way from the right-hand side to the left-hand side or the other. So I thought, okay, great, I will put trim and it will trim the blanks. But surprise, it doesn't, because it just trims the trailing and the initial blank. So there's no blanks in my string, it prints back the same thing. So then I was thinking, okay, is there a way to get rid of the blanks? And I thought, okay, maybe I can replace the space character with no character. But then I realized this is not possible because, as we said, I mean, well, you can replace character for character, you cannot replace character for nothing. So then I thought, okay, maybe a nice example is to replace blanks with white spaces with dashes, and this is what you get. And now note that all these are constructive, so my original string remains the same. So I can do, I make all these tests, but then the original string remains the same. So now if I change all lowercase letters of string to uppercase, I will get this, where you see I don't have the dashes because I didn't change the original string. And then what else did I do? Oh, I took the substring from 0 to 4. So let's see, 0 is this one. 1, 2, 3, 4. So since this is exclusive, I should get back never. And then I wanted to compare this string with this string. And now this is alphabetically before that. So since I called the compare on the bigger string, I should get back a positive number. Okay? Any questions? Come again? That's a great point. Yeah, so I was thinking about the same. So the question is, shouldn't the substring this be never, right, with the R? That's what you're saying. But then remember that we said that you take the substring from 0 to 4, including 0, excluding 4. So then it's, yeah, this is excluded, so you get up to that point. Another trick to remember this is that the substring, you return a substring of size, the size of this index, I mean, the size of the substring would be this minus that. So you get a substring of size 4, 1, 2, 3, 4. Okay? All right. Okay, so that was a very quick demo of how these things work. Let's swap again. Okay. And then what about string equality? There are two ways to compare strings for equality. And one is to use the equals method. And the equals method is a method that you have in the class object. So basically, all your objects will have it. And if you're lucky, they will actually override it and have a proper implementation of equals. So for strings, equals means string equality, like the value equality. Are they the same strings? Do they have the same characters, if you like? There is another way to compare them using equals equals. But that has strange behavior because it's an alias test. It tests whether the two variables, str1 and str2, are the same, refer to the same object string. And sometimes this is not what we want. We just want to check, well, most of the times we just want to check that our strings are the same, letter by letter. So we will basically, well, almost never use that and use this instead. And aliasing for strings sometimes can be a bit arbitrary, or like seem a bit arbitrary. Obviously there's a logic, but sometimes it can be obscure. So that's a reason why not to do that. Actually, I have another demo to see that. So suppose I have this code. So what do I do here? I create 4 strings. The first 2 strings, str1 and str2, are just the literal test. Then I create a new string, str3, which is again test, but I call the constructor of string on it. And then the 4th string, I call the constructor string on the 3rd string. And obviously I want to check which of these are going to be equal. And first of all, I compare them all for value equality. So str equals str2, str2 equals str3, 3 equals 4, and so on. So if what I told you that equals is value equality, then all these strings should have the same value equality, so they should be the same. So that would be great. And then I compare them, though, for reference equality. And then we're going to be there's a bit, yeah, there is a logic behind it, but if you were to write code, you might get it wrong. And it's not what we want anyways. So I compare the two literals for equality. I compare 2 and 3 for reference equality, 3 and 4. And then I even compare the literal test to the literal test. You might be guessing what this will return. You might be surprised. And then to surprise you, I will show you that if I get, well, actually, let's run the demo, and then we'll see what we get. So we were at this point. We're running the previous demo. Let's see if we can fit both. Well, we can, but maybe if I put it this way. Oh, there you go. So now we'll print the first test, and it says, well, it says true, true, true. That's great. So the 4 strings are, well, 1 is equal to 2, 2 is equal to 3, 3 equals to 4, so they're all equal as far as their values are concerned. And then I will compare, maybe I could put it like this. Now we can see both of them. Now I compare 1 and 2 for reference equality, and now because these refer to the same literal test, they are the same object. 2 and 3, though, are not the same because 3 created a new object. And even 4, which is a copy of the previous object, well, it's a new object, so they're not the same. And even if I get, well, and test are true, okay, as literals. But now remember that str1 and str2 were the same, and now I say, okay, why don't I compare str1 with str2, where in the end I have added the empty string. So you would think that adding the empty string at the end of the string doesn't change much, but if you run this, it will say they're not the same. Anyway, you're not expected to know what this test will return as far as reference equality is concerned. It's just to show you that the behavior sometimes is not obvious. So we will be sticking to using equals. Any questions? Okay. Okay. And then finally, okay, there was, well, you might have thought it yourself, okay, we talked about compare, so if you want to compare two strings for equality, you can just, well, compare them, and then if compare returns 0, because we said it returns 0 where they're the same, we say they're equal. So you can do that as well. Okay? Okay. And then we saw this already in the examples, that you can concatenate strings. And you can concatenate strings using the plus operator. So if you have, for instance, Black and Berry being two separate strings, and you print str1 plus str2, you get BlackBerry, for instance. And you can convert every object to string by using the toString method, so you get a string representation. And in most cases, so this is a toString is a method you have in the object class, so all your objects will have it. But sometimes it's not properly implemented, so you will get back a string representation, a character representation of the reference of the object. So it will be a memory location, basically, so it's not very useful. But sometimes for strings, there is properly implemented, so you get back, for integers, for instance, you get back a string that represents your integer. For booleans, you get false or true as strings. So for instance, if you remember here, I was printing in this demo, and I would say, okay, this is, so let's see what I put here. I put a string. I want to print a string, which is this one. New line, strings values are equal. And then I said, okay, concatenate it with this guy. Now, if you remember, equals returns a Boolean. So this was concatenated with a Boolean, and then the plus operator, automatically calls on this Boolean the toString, so it takes the string representation. So if you remember, the result I got here was, true, true, true. So you got the Boolean true, and you transformed it into a string straight away. And this is very convenient, obviously, because you don't need to have explicit conversion of my Boolean into string and then print it. You do it automatically. So here I concatenated this string with the string representation of this Boolean, and then I had another string, and then I had the string representation of this Boolean, and another string yet. So the string just contains a comma here, and then this other Boolean. And similar here, I had a string concatenate with, well, this is returns a Boolean, and so on. Okay? Any questions? Okay. So this string concatenation is very straightforward in Java, so it's done by the plus operator. And you can also concatenate strings with other objects which are not strings. So this is the bottom line, and then automatically the compiler will call the transformation of this object to a string using the toString method. Okay. And then remember we talked about recursion. We said, okay, recursion means a method makes call to itself, to the same method. You define a method. So for instance, let's say we want to define a method starts with, let's say we give it str1, str2, returns true, just if, so this means if and only if. The string str1 starts with str2. So for instance, Fred starts with fr, but I don't know, Fred does not start with okay? So it's a substring relation. You have a string, str1 is the string str2, an initial part of str1. So that's what starts with means. So how can I check that this relation starts with is true between two strings? There is a very easy, notionally if you like, easy way to check that. Suppose that you have two strings that are not the same. And you want to check whether the second one, str2, whether the first one starts with the second one. Well, you can say the following. I will compare the first character And if the first character is the same, then I have chances that one starts with the other. So if they're the same, then the first one starts with the second. So let's see. I have my str1 here, and I have my str2 here. I check these first characters. If these guys are the same, then I'm happy. All I need to do is to check if these guys are substrings. So I have to check if this guy starts with this guy. Because if this holds, the first character being the same means that I can extend this being an initial string to the initial strings str1 and str2. But if these guys are not the same, then, well, it's hopeless. They cannot start with each other. It's like trying to see if, I don't know, Fred starts with, I don't know, some string that starts with K. Well, that's never going to work. So the good thing is I can do this recursively. So I can actually, I mean, this reasoning that I explain in English, I can write it down in code. And how can I do that? So I do it as follows. So I have first some conditions to check, okay, if my strings are empty, then I can decide straight away. If the second string is empty, so remember I had Fred being str1, say. If str2 is the empty string, then I'm happy. The empty string starts every other string. It's the beginning because it's empty. So if the second string is empty, then I'm happy and say, yeah, the first string starts with the second string. If not, so if this test doesn't pass, then I can go to this line and say, okay, now let's check the first string. If the first string is empty, and the second one is not empty, then, well, I have the empty string starting with a string that is not empty, then this is not the case. I mean, you cannot have that. Basically, you're saying that you have a string that starts with another string which is longer than it, and this is obviously false. If neither of this is the case, then I compare the first string of the one to the second string of the other. If they're different, I say it's false. Otherwise, I call myself again by taking the substrings, leaving out the first characters. So basically, I'm doing what I was saying here. I compare the first element of the strings. If they are not the same, I say straight away return false. Otherwise, call again substring, starts with on these two guys, which is this one. So this is str1 substring 1, and this is str2 substring 2. Okay? Now, in this code, what you might find a bit difficult to grasp straight away is the initial conditions. Why do we say this is the same? But I think it's, I mean, we explain it here, but it's also interesting if you try it yourself on some larger strings to see how this works. And also the fact that we don't have if then else clauses. So we have if then, and then the else of this if is this bit here, but we don't need to say it because, well, if this condition holds, then you return, and then you don't do anything else. So you don't need to have if then else. So it's just shorter code. Okay. And now one can ask, okay, is this a nice algorithm? Well, it's nice notionally. I mean, it's intuitively it's easy maybe to understand, but it's not very nice in the sense that you have all these calls to the same method. And now you remember we said that strings cannot be modified, so you always create new strings and pass them around. So you create many, many strings, which are substrings of the same string. So it's not very convenient. So you make different calls to the same method with different variables each time, and this can be a bit memory consuming. Yeah. So on the other hand, if we had an iterative solution, we can have a for loop that goes through the two strings, string 1 and string 2, before they finish. So as long as we don't hit the end of the strings, you go until and you go in this loop until you find the character where they differ. And if you find the character where they differ, you say, okay, they're not equal. So basically what it says, if you find the character that they are not equal, you break the loop, and then you see where is this character. Is it at the end of your string? So have you exited this loop because the smaller string finished? Or did you exit this loop because your first string finished? Or because you found a different character? And if you exit the loop because the first string finished, it means, okay, that you went to the first string, you first did the second string, you checked one by one, they were all the same, and at this point you left the loop, and then you can say, okay, obviously this is a substring of that, so it's an initial string of that. In every other case, this is not, the first string doesn't start with the second. Anyway, the moral out of this is if you compare this code with the code we had before, is that, well, maybe this code is a bit intuitively simpler, but on the other hand, it's not as efficient as the iterative code. So strings are usually best processed using iteration. Okay, any questions? Okay, so basically that's what I want to say about strings. So this was, strings are something that you had seen maybe quite a lot even before. Whereas the next class I want to talk about is, well, maybe not as known to you, and it's array lists. So array lists, if you like, are like arrays, but they are better, like arrays reloaded. So they're like arrays, but equipped with some additional methods which makes the manipulation easier. So for instance, you can resize them, you can add items to them, you can truncate them, you can also call iterators on them. They're very, they have lots of methods you can use of them. And they form part of the collections framework of Java. And collections are just, well, generally are objects that can carry different objects in which there are ways of grouping objects together. So array lists are one such collection. We're going to see more further on this module. It's okay. So what is the type array list? So array list is a generic type, so it's a generic class if you like, and it's written like this. Array list E, and E is a type variable. And it stands for any type. So basically when you write array list integer, this creates, if you like, if you put in constructor, an array list of integers. If you write an array list of string, you get an array list of strings, and so on. It's important to note here that the type you're going to put in place of E has to be a proper type, so it cannot be in particular a primitive type. So you cannot put int, char, float, or boolean. Instead, you have to use the wrapper classes that return objects, integer, character, float, or boolean. Let's see. And what methods can we use on an array list? So we have A to be an array list of some type. So it's an object array type, so this can be integer or string or boolean. Then get I fetches the ith element of your array list. So you can think of array lists actually like arrays, but where you can call more methods. But then the other difference is that whereas in an array you would say AI to get the ith element, you cannot do this anymore. You have to say A get I, and this reads the ith element. And if you want to write, you have to use a different methods, and you say set, so it's get for reading, set for writing, and you say set I, the ith element of my array, to be V, of my array list. And you can also add things at the end of the array, so you can add the value V at the end of A being an array list. You can also say add V at the position I, and then everybody who's after I is going to be pushed one way to the right, one position to the right. You can even remove elements very easily. You can say remove I, and removes the element in the ith position. And remove V will search for the value V, and then the first time it finds it, will remove from the array. So these are very, if you remember with arrays, defining these things was non-trivial. We had to write methods. Well, here the methods are given for array lists. And all of these methods are destructive. So when you call this, A is changed in this way by removing the ith element. If you want to get the size of the array, on the other hand, you just call the size method on A. Okay. And as any object, in order to create an array list, well, you have to declare a variable for it and then start it, and then call the constructor on it. What is interesting with array lists is that when you start them empty, and then in order to add elements, you have to use the add method, which is a bit different with what we had seen with arrays, where you can, I might be confusing to say arrays for arrays, but yeah. So arrays, you start them empty, sorry, array lists, you start them empty, and then you fill them with add, whereas arrays, you start them with different elements, and then you have to put the elements inside. So for instance, this code I wrote here creates a new array list of string that is initially empty, so it's empty, and then you add steak, and then you add salad. And this is the way to get an array list of size 2 that has these two elements. Okay. Well, now we have some examples. Let's see. So this, well, basically the examples do this. Let's see, what do I have here? I have I create an array list of integer, and then I want to check what is the first element of the array list. Okay? Now, let's see. So I had to do this, array list, a new array list, and then I get the first element. So I was here. I have already, I have to recompile. Okay, this we have seen. And then I try to get the first element of the array, and well, as you can see, I got an exception. Because, as we said, well, they're created empty, so, well, it was just silly of me to try to get the first element, because I get, what do I get? Index out of bounds exception. Now, there is another constructor I can call, which you can give it a value, an integer, when you construct the array list. So let's try this one. So I call the constructor with the integer 2. And then you might think that this is okay, but it's not okay, I get an exception again. So what this does, it always creates an empty array list. But if you say 2, internally it creates a structure that will eventually cope easy with 2 elements. But in theory, but it returns you something that is empty anyways. So this was never going to work. So let's try now my new code, which says, okay, create a new array list, and then add 4 elements, and then get the first one. So this should work. Let's see what it does. So it says, okay, it returns the first element of the array list, and it's 5. What did I want to do afterwards? Okay. And now, this is an important example, because what I wanted So the element you had first remains in first position, the second goes the second position, and so on. So I added 4 elements starting from 5. When I call get on the first element, this returns 5. Maybe I can do it. Okay. On the other hand, I said remove 3, and okay. So I don't know how much you can see of that. So okay, so I say before removal, this is my array list. And now if you see the code I called here, I called the toString method on A. So you can see that array lists have a very nice toString method where you have an array list and it prints it as a string, exactly as you would expect it. So yeah, it prints it like that. So I didn't do anything. I just called toString, and this is what I got. And then I said, okay, I want to remove 3. Now I have the element 3, but remember there are 2 methods, one for removing the element of the index 3, and one for removing the value 3. And now if I count here, I have 0, 1, 2, 3. What it understood is remove the element at position 3 and return this. If I want to really remove 3, I have to call like this. I have to give it an integer value 3, and it will remove it and give me back this. Okay? Okay, so that's a short demo to see how this works. Like, let's see now. Here is a table of how do arrays and array lists compare. You declare them in a similar way. Think brackets, square brackets is array of thing. Whereas for array list, you use this notation, and this notation is specific because, particular to the, it's used like this because array list is a generic type. And you access values of arrays like this, and these are like variables where they have a variable inside this index, so it's like variables. Whereas with array lists, you get and set them separately with different methods. Arrays have fixed size, array lists can change size, and the sizes are with length or with the size method. And then we said array, you create one and then fill in its elements, but you create it with a specific size given. Whereas array lists, you create them empty and then you add elements using the add method. And they're also implemented differently internally. Okay? So what else can we do with arrays? We can copy them. And you can write a method for copying an array, which is, well, basically you create a new, an array list. You create a new array list, and then you start adding elements until you have finished, like you have reached the length of the initial array list. But another way to do it is you call the constructor. So you have the new array list, you have an array list A, you have added these 4 elements. Then you can create a copy B by calling the constructor using the original array list as an argument. So this will do the following. If you had A here, it will create a copy of it, which is B. And this is a shallow copy. If this guy was referring to some other object, you would get a copy referring to the same object. It is not the same as B equals A, because B equals A, it would say, here's my A, and here's my B. Well, I have been imprecise here. So this is A, and this is B. And this would say, whereas this would say, if I have B equals A, I create a new reference to the same object. Okay? So this is copying, whereas this is aliasing basically. Okay? We can also make a copy of the array list using cloning. And cloning is inherited from object. But then we have to be a bit careful with casting because otherwise the compiler is unhappy. You can also search for an element in an array list using the contains method and so on. Well, the best way to find out which methods you have for a list is just to go to the documentation. Especially when you write code, you might find it useful. Because sometimes you think, oh, I need this method, maybe I should implement it, but then you go to the documentation and the method is already there. Okay. And our final thing I want to say is, well, we said that array lists are generic types. You can have array lists of integers, array lists of strings, and so on. And an array list of strings and array list of integers will have very similar structure. And if you want to write code for them, the code might have similar structure. So for instance, here is a method that I have done for destructive chains on an array list. So what does this do? You take an array list A, integer n1 and integer n2. It goes through the array list, and if it sees that the ith element is n1, it sets it to n2. So it basically replaces each occurrence of n1 with n2. It's like the replace method we saw for strings, basically. So if you have my array list of integers, and I want to do dechange A and change all the zeros to ones, the method will see, whenever it sees a 0, it will set to 1, and so on. Now this is a useful method for changing the elements of an array list, so you might want to try to write the same method for an array list of strings. So how can you do that? Well, you will need to write a method that has a for loop that goes through all the elements of the array list, and whenever it says the first string, replaces it with the second one. So if you like, if I go here and change this to string, then this method will work on array list of strings, exactly the same, apart from changing the types. So yeah, you can see that, well, if I were to do that, there's a lot of duplication of effort because I'm writing the same method twice, just changing types. But then, because array list is a generic type, I can write it in a generic way. I can say, well, here is a method that applies for every type T, array list of every type T, and then when you call it, you just put the array list there, you put the elements you want to change of the right types, and the compiler automatically knows what to do. So here, note I have this T here instead of integer or string, and this T is a type variable or a type parameter, if you like. And the way you write this, you say, okay, this is a method that is generic over this guy here, T. So T is a parameter type variable, and it's the same, and this method applies to every type you put in place of T. And the syntax for this is you put all the type variables of your methods before the return type, which is, in this case is void, and then you're allowed to use these type variables inside the definition. So this basically says this is a change method for array list of type T with arguments of type T and T for any T. So you write this method once, and then you can call it, for instance, on an array list of integer. You create it, you add some methods, you add some elements, and then you change, for instance, 4 to 5. Or you create a new array list of strings, you add 2 strings to it, and then you say, okay, now change start to state. And this kind of parametric writing of methods is actually very useful. And this is another reason why array lists are very handy and very useful in general. Okay? All right. And our final remark I have here is, if you look at the code, I have used equals here for comparing. So I go through my array list, I compare all the elements with the method, the element I want to change, and if they're the same, I change it to the other element, x2. So why I'm using equals and not equals equals? Well, we said before, because what I'm interested in is value equality and not reference equality. If I were to put reference equality here, it would work for integers, but it would break for strings probably. So yeah, that's why we use equals. Okay. So to sum up, we have, so Java provides many classes as part of its standard libraries. And well, we can use them as we like, as long as we know how the public methods, what they do. And we saw that the string class is very useful for handling text. We also saw a bit in the example how to use scanners, but scanners are very good for reading text. And then we also focused on array list, and there is, if you like, a more evolved way of arrays, of using arrays. So it's like arrays with a lot of methods added to them. What is important to know is that you don't need to memorize all of these Java classes and their methods. You just need to know the basic functionalities. For everything extra, you can go to the documentation. And then finally, the array list we saw is just one of the collection classes that we have in Java. We're going to see more in following weeks. Any questions? Okay, if you have any questions, incidentally, the best way to communicate them to us is through the forums. Because you will get an answer, but then other people will also see the question and the answer, and then so more people will benefit. Okay, thank you.
I'll probably go through a radius and run it in 5 minutes anyway.
Yeah.
The guy just asked me. So the guy said, well, I understand it all. Some students do, some students don't.
So you go again on Friday, so
Yeah, I know I should be going through some of the exam question radius.
oh, okay.
Should obviously go to some specific detail.
It's very, yeah, I have the feeling that some people follow and some people are bored and some people have no
This is
idea.
a real problem. Some people would not got it. Some people are bored because they understand it perfectly. I think so we're well split out, I hope it will work, but those who need to go summarise see the end, where those that have got the basis, hopefully the exam questions all the time. So that was reasonably good. I counted the number. 130 to 200, so it's 7.5.
How many students are there in 200? 200.
200.
turnout, I think we had even more.
Yeah, it looked like quite a full turnout, but I think because the Great Hall's a big place, I counted the number. Something like that.
I want to make this change with the for loop, but then I forgot. The while loop, so then I just said the for loop. But yeah, I think that it, yeah, even when I was saying the example then with the returns of the if analysis, yeah, I think if students don't pay attention and then try to, they just don't get anything. They don't see why.